All right, so in 13.3, we are graphing proportional relationships. Now, what you need to understand about proportional relationships is that this is a type of linear equation. All right, does anybody remember what is a linear equation? What does it form on a graph?
A line.
A line, okay? So, not all linear equations are proportional relationships. It could be a linear equation, but not necessarily a proportional relationship. All right? So what makes a proportional relationship exactly what it's called, or what makes it special? Okay? How can I identify it? Well, I identify it according to the equation y equals mx. Y equals mx. And that should look familiar to you. All right, it's the first part of slope-intercept form, y equals mx. But there's something very specific happening here. M is what we call the constant of proportionality. M is also, all right, so that's what we have over here in this peach box too. It's the constant of proportionality, but it is also the slope and the unit rate. It has all of these characteristics. All right, so it's telling me the rate of change between x and y. That's going to make more sense in a minute. But you need to understand, guys, if I change m, then I change how x is related to y, or what is happening to x to produce my y value. All right, again, that's going to make more sense once we start actually looking at these equations. All right. But that m value, that's what we're really focusing on here. All right? So what also makes a proportional relationship different? All right, a linear equation is a straight line on a graph. But a proportional relationship passes through the origin on the graph. So this is actually really easy to identify if we know what we're looking for. If the line passes through the origin, like you see here in this picture right here, if it passes through 0, 0, it's a proportional relationship. If when x is 0, y is 0, it's proportional. All right? And I know I keep saying it's going to make more sense in a minute, but it will, okay? Once you understand and we start kind of attaching a description or a label to x and y, it makes it easier to understand what's happening here in the equation. All right, but m is my wild card. If I change that value, I'm changing how x and y are related. Okay, you got that? All right, so what if I asked you what variable in the equation stands for the constant of proportionality? You would say m. Okay, and if I asked you a proportional relationship must pass through what? The origin, okay? So if it doesn't pass through the origin on a graph, it is not proportional. It's still a linear equation, but it's not proportional. All right, so let's talk about this slope. Remember, my format is y equals mx. So what's happening here, okay? Well, let's look. The cost, so y stands for the cost, how much money, how many dollars, of ice cream per ounce. Okay, so this is what the m value is telling me. All right, you've got to understand this. Now that you're looking at the equation here, okay, y equals, so y stands for what? The cost. X stands for however many ounces. So let's just give x a random value of 1, okay? If I gave x a value of 1, y equals, and I want to buy 1 ounce. So let's say I walk up to the counter and I say, ma'am, I would like to have 1 ounce of vanilla ice cream. How much is she going to say your cost is? $3. Do you see what we did there? Okay? I want 1 ounce of ice cream. It's going to be $3. So what does this tell me? This tells me that this number right here is my cost per ounce. So what if, according to this equation, what if I go up to the cashier and I say, I'd like to purchase 2 ounces of vanilla ice cream, yogurt, whatever it is, ice cream. So I plug in a 2 here. I purchase 2 ounces. How much money is that going to cost me? $6. Okay? So that M value, that's telling me how much money it costs per ounce. So what do you think is happening? Let's say that these are 3 different ice cream shops. Ice cream shop 1 is $3 per ounce. Ice cream shop 2 is $2 per ounce. So I go to ice cream shop 2 and I say, I want 1 ounce of ice cream. How much money is it going to cost on the second one? $2. Okay, a little cheaper. Now what if I go to the third ice cream shop? How much is it per ounce on the third one? 75 cents. Who do you think has the most customers? 75 cents, right? Unless it's ice cream that is like has food poisoning or something, right? Okay? But do you see, guys? Listen, in all 3 of these equations, if you can see this, this is really important. In all 3 of these equations, X and Y stood for the same product, right? X stood for ice cream in all the equations. Y stood for the amount of money in all the equations. But because my M value changed, that changed how much money it was going to cost me, right? Right? Okay, so that's what businesses do, right? Has anybody ever seen a pharmacy open right next to another pharmacy? Yep. Yes. Okay. Those, right? Guys, listen, pay attention. Sometimes, now I'm not saying it necessarily happens with pharmacies, but why in the world would a business of the same kind open up to next to another business? It's competition. And what do? They drive down their prices, right? So one, if you see Home Depot running a sale, odds are Lowe's will honor that sale, and Lowe's will give you the same discount, okay? It all comes down to this type of variable, okay? So same products, but what's affecting the cost? That is your rate of change. That's your slope. Is that making a little more sense? Okay, that number connected to X, that is changing how X and Y are related. So let's look at, again, I just kind of stuck with the whole ice cream theme. Now it's yogurt. It's the same thing, okay? Anybody prefer frozen yogurt over ice cream? Can anybody not tell the difference?
I cannot.
Not really? Has anybody ever had frozen custard? Oh my goodness. That stuff is like manna from heaven. It's amazing.
Manna from heaven was nasty.
Yes. But it was life-sustaining. Yes, it was. All right, here we go, guys. The cost. Hey, we are going to graph this. You can do it on your paper. We are going to graph this, guys. Pay attention. The cost, Y, in dollars for X ounces of yogurt is represented by the equation Y equals 4X. Graph the equation and interpret the slope. Y equals 4X. Well, in order to graph this equation, I need ordered pairs. All right? This is not new for us to make up ordered pairs, but in order to make up ordered pairs, I need a what? Anybody remember? How do I just come up with ordered pairs? I need a X, Y table.
Right.
I need a table. Okay? However, think about what X stands for here. What does X stand for in this equation? No, what does X stand for? Look at the yogurt. Is it possible to go up to the cashier and say, Miss, I'd like -2 ounces of yogurt?
No.
So are you going to use negative X values? No, that doesn't make any sense. All right, so our standard set of numbers before involved a negative. We're not going to have negatives here because you don't order negative ounces of yogurt. Does that make sense? Okay, but 0 is important. So I am going to stick with 0. Now I know that this kind of seems like a little odd. Who would walk up to a counter and say, I would like 0 ounces of yogurt? But think about it practically speaking. If you order no yogurt, how much are you going to pay? $0. $0. That's what we're showing here, okay? That shows a proportional relationship. If I order nothing of this product, I pay nothing. There is no like base fee, okay? Has anybody ever gone somewhere where it was like just $5 to like get in? to the place and then you paid. All right, there is no entrance fee to get into the store. It's not like, okay, pay $5 before you can even come in the door. No, it's if you order the product, you pay. All right, that's basically what it's saying here. So the ordered pair is 0, 0, a proportional relationship. Okay, so what happens if you order 1 ounce of yogurt? You pay $4. Okay, what happens if you order 2 ounces of yogurt? Do you see what we're doing here, guys? Before we would just say y equals 8, but now we're saying you pay. You're applying the topic here. You're saying I understand that y stands for dollars. That whatever my y value is, that's money. That's what I'm paying for this product. Okay? You with me? You get what I'm saying here? Okay. So now I have ordered pairs and I can graph it. Go ahead and plot these points on your graph. Mine's going to go a little bit off the graph. That's okay because I need to go up to an 8. All right, go ahead and plot these points on your graph. All right, so we go 0, 0, 1, 4, 2, 8. And it's still a linear equation, but here's what's significant about a proportional relationship. It passes through the origin, and we're showing that here on our graph. So what does this mean, okay? Well, this number that's connected to x, that's the number, okay, that is affecting x and turning that value into whatever my y value was. So that 4 means what? My slope, okay, for every ounce of yogurt that I order, how much is it going to cost me? It's going to cost me $4. So if I order 1 ounce, it costs me $4. If I order 2 ounces, it costs me $8. Guess what's going to happen if I order 3 ounces? $12. So my slope, my rate of change, this number tells me that I am paying $4 per ounce of yogurt. Okay? So if that number was lower, 75 cents, $2, $1, okay, that would tell me how much money per ounce it was going to cost, and I could predict my cost. All right, that's what it's asking me to do here. All right, in the next example, we're identifying a proportional relationship. There has to be a constant rate of change. On a graph, I'm looking for the line to pass through the origin. If it passes through the origin, that's my reason. If it doesn't, that's my reason why not. Okay? So on this first graph, you don't necessarily have to sketch the graph, just look at it with me. All right? Does that graph represent a proportional relationship? Yes, because it passes through the origin. Okay? Now, there is a very easy way to identify. If you say yes, you have to tell me what the equation is. What is the rate of change between x and y? Okay, there's an easy way to tell that. All right, so you would say yes on this one. And you would go over, now, x does not have a category. I mean, we could give it a category. We could still use the yogurt example. Okay, so let's do that. Let's say x stands for ounces of yogurt, and y stands for cost over here. All right, so at 1 ounce of yogurt, how much did it cost? Okay, so rise over run is 1 over, rise over run. We got to go rise over run. So it rise is 4, so $4 per ounce, 4 over 1. That's my equation. Y equals 4x. For every ounce, look at this. Go up 4 more and over 1. Up 4 more and over 1. That's what the line is showing me. That for every 4 units that y increases, x increases by 1, 4 over 1. So if your answer is yes, you have to write an equation. You're going to see that on your homework tonight. Okay? If your answer is yes, you need to write an equation. The number here, your slope, is calculated rise over run. So you can count that on the graph. Are we clear on that? Okay, now let's look at the table. There should be a constant rate of change, meaning I should be doing the same operation to X to produce Y on all of these if it's a proportional relationship. Okay, so how could I get multiplication and division? How can I get from 2 to 4? Multiplication or division, guys? Multiplication by what? So, according to the first order pair, it's y equals 2x. Does it work for the second order pair? No. So, this has to be the equation, but because it does not work for all the ordered pairs, I would say no. There's no constant rate of change, and I'm going to abbreviate ROC for rate of change. Okay, there's no constant rate of change. I can't do the same operation to each X value to produce Y. You see that? Okay, so it all comes down to the rate of change. Is there a constant rate of change? All right, any questions? One more example. Okay. All right, so here's what's going on here. Let's read the example together. The distance y in miles that a truck travels on X gallons of gasoline is represented by the equation y equals 18x. Okay? Now the graph shows the distance that a what travels? A car travels. Okay? So I have an equation for truck. Y equals 18x. Okay? Which vehicle gets better gas mileage? Okay. How do you know? What is it? Okay, so let's go to the truck. Let's start here with the truck. So for the truck, we said y equals 18x, right? Okay, so x stands for what? Gallons, right? So if I plug in a 1, let's say I want to put in 1 gallon of gas into my truck. 18 times 1. How many miles is it going to go? 18. Okay, y equals 18 miles, right? All right, so what is that showing me? That I get, this number right here tells me how many miles I get per gallon. So what happens if I put 2 gallons of gas in my truck? 36. I go 36 miles, okay? So the truck gets 18 miles per gallon. Now look at your graph. Go over to 1 gallon on the car. On 1 gallon on the car, how many miles did it go? 25. All right, so to answer A, okay, you don't necessarily have to show this work over here. I'm just kind of showing you basically what's happening there. On A, you would say the car at 25 miles per gallon is greater than the truck at 18 miles per gallon. You see, guys, how I'm not just saying, oh, the car is more. I'm specifically saying, I know how much the car is, and I know how much the truck gets per gallon, all right, because I tested that value. Okay, and that's my explanation. That's how I found my answer. So let's look at B. How much farther can the vehicle you chose in Part A travel on 8 gallons of gasoline? You've got to be able to show this, though. Okay? So we have one equation, y equals 18x, for the truck. How could we write an equation for the car? It's going to look pretty similar. Exactly. Y equals 25x. Now, what am I testing? 8 gallons. So I'm going to plug in 8 for x here. The gas pump doesn't care what kind of vehicle I'm putting 8 gallons in, but depending on what kind of vehicle is getting the 8 gallons, it's going to depend on how far it can go on those 8 gallons. If you put it into a Hummer, it's not going to go as far as a little smart car, right? Okay, 8 gallons is 8 gallons, but depending on what kind of car you're putting it into, it will depend on how many miles it can go. That's what we're doing here in B. we're plugging in 8, and we're saying, so if we have a long drive to work, do you think this is going to add up?
No.
A truck? Yeah, absolutely. If I have to drive 50 miles one way to work, you think I'm going to be driving a F-250? No, because that would just eat up gas, right? Y equals 18 times 8, and y equals 25 times 8. So how much, what's 18 times 8? And what's 25 times 8? 200. So how much farther did your car make it? 56 miles longer. That's the answer to B. Okay? All right, you see how we did that?
Yes.
Okay, proportional relationships are a type of linear equation, but they have a direct connection, meaning there is the same rate of change happening from X to Y in each of the ordered pairs. All right, and that's everything you need to know for today's lesson.